Gary Griggs, and I'm a professor of Earth and Planetary Sciences here at University of California, Santa Cruz. So shoreline retreat, and there's really two processes we could think about. I tend to think about shoreline retreat as the low-lying beach areas where actually the shoreline is gradually moving inland as sea level rises. The other is cliff or bluff retreat. So if you think about Santa Cruz, Main Beach and Seabright Beach, the shoreline will continue to move inland. If we look at West Cliff or East Cliff, we've got a cliff that's retreating. So that's a one-way process. It doesn't come back. Whereas the beaches, if the weather gets better or more sand is added, the beaches can actually accrete again. So there's those two different processes that are affecting us. Some areas are more heavily impacted than others, depending on if the edge is a sewer line or a road or a bike path or a highway versus maybe a place where there's nothing really at stake. In the extreme, probably a foot per year of cliff retreat on average for Santa Cruz. If you go down to the southern end of the bay where it's sand dunes, it's up to 6 or 8 feet per year on average. And what happens, however, is we get a big event like a big El Nino with an elevated sea surface and then high waves and high tides. It can go back 6 or 8 or 10 feet in a storm, and then it may be calm for a couple of years. So it's an episodic process, and you can't predict it's going to be 1 year this year, or 1 foot this year, 1 foot next year. But there's a lot of properties that are threatened, houses that are threatened, and we're now at this sort of departure point where seawalls and revetments have been the standard method of responding to shoreline erosion for 100 years in California. Thousands of houses on the coast that we're assuming they could build some protective structure. But with sea level rising and changes in storm climate, there's going to be some major problems. I mean, I would say billions of dollars in real estate are at stake. In a natural world, if we let the shoreline move back, the beach will just move back with it. As soon as we fix the back beach, say Main Beach or wherever we have a wall, as sea level continues to rise, we're going to basically drown or flood the beach. So there's going to be a huge public loss in the long run of California's beaches that are backed by roads or railroads or hotels or seawalls. So there's a long-term, very large negative impact. We call that passive erosion. It's just, we're going to flood the beach. Beach sand replenishment, which has been the big East Coast solution. It's very expensive. We've done some of it in San Diego. We find an offshore or onshore supply of sand. We pump it on the beach and widen the beach. It's generally very short-term and very expensive. It might last a year or two when it can be tens of millions of dollars. It's not a long-term solution. The ultimate solution, we can call it many things. We can call it managed retreat. We can call it stepping back from the coast, relocation, adaptive management. I'm not sure what the adaptive management means, but this whole idea of resilience, how do we respond to this? Ultimately, it's connected to how high sea level rises and how fast. So around the world today, there's 150 million people living within 3 feet of high tide. Around the US, there's something like 6 million people within 6 feet of high tide. We could hit 6 feet by 2100. And because sea level is going to continue to rise for decades because of what's already built in the atmosphere. And the question is how fast, and we've now kind of developed probabilities based on what might happen with Antarctic ice. But the quicker that happens, the more we're going to have to respond. And we can only build walls so high, we can only put so much sand. So ultimately, it's going to be stepping back, planned relocation, unplanned relocation. And that is a huge pill nobody wants to swallow.